Sometimes it's not possible to solve a trigonometric equation with identities that have a multiple angle, such as an equation that contains sine of 2x or cosine of 3x, or the following equation. When confronted with these types of equations, we need to recall that a multiple angle is just telling us about a horizontal compression or a horizontal expansion. Let's go ahead and look at the graph of cosine of 2x and cosine of x with this equation in mind. On the interval of 2 pi, we'll only have one period of our cosine x, and we'll have two periods of our sine x. We'll let the blue curve be our cosine x, and the yellow curve will be our our cosine 2x. Here, these green points indicate solutions to this equation on the blue curve, and these correspond also to points that are solutions of the yellow curve. But then we also see another set of points over here on our yellow curve that are also going to be solutions to this equation here. Therefore, this leads us to believe that there should be twice as many solutions for this equation cosine of 2x is equal to 1/2 as compared to our cosine of x over the same interval of 0 to 2 pi. Now let's go ahead and find all solutions for the equation cosine of 2x is equal to 1/2 on the interval from 0 to 2 pi. To find all solutions to this equation, we'll first set our 2x equal to some alpha. And then we'll find a solution for our cosine of alpha is equal to 1/2. We know that cosine is going to be positive in the first quadrant and the fourth quadrant. This means we form a right triangle in both of these quadrants. The adjacent side has length 1 and the hypotenuse has length 2. Therefore, the opposite side of both of these triangles is going to be given by the square root of 3 and the square root of 3. The reference angle for both of these triangles then, so we'll call both reference angles just equal to theta real fast. And this is going to be given by a pi divided by 3. Therefore, the solutions to this particular equation is going to be given by the following. Alpha is going to be equal to a pi divided by 3, since this is given by the first quadrant. And then we'll also have a 2 pi minus pi divided by 3 as our second solution, which is the same thing as 5 pi divided by 3. So our solutions, again, alpha is either equal to a 5 pi divided by 3 or a pi divided by 3. And remember that we had our alpha was equal to a 2x here. Therefore, we'll get two solutions to our equation. Either we'll get that 5 pi divided by 3 is equal to 2x, or we have that pi divided by 3 is equal to 2x. This gives us that x is equal to a 5 pi divided by 6, or x is equal to a pi divided by 6. So the question now is, are there any other possible solutions? And the answer is yes. Let's go ahead and look at our picture again real fast. Here on the graph, what we see here is that the solutions that we just found lie between 0 and pi. Therefore, from this picture, we should have two more solutions. And to find these two solutions, since trig functions are periodic, we're just going to add 2 pi again. So let's go ahead and take these equations here and rewrite them real fast. We'll go to a new page. And take our 2x, and this is going to be equal to a 5 pi divided by 3 plus 2 pi. And our other equation is going to be 2x is equal to a pi divided by 3 plus 2 pi. Simplifying these equations, we'll get on the left-hand side a 2x is equal to an 11 pi divided by 3. And on the right-hand equation, we get 2x gives us a 7 pi divided by 3. And finally, we'll get x is equal to 11 pi divided by 6, or x is equal to a 7 pi divided by 6. Therefore, this equation has four solutions, and we'll just go ahead and rewrite these on the next page. Either x is equal to pi divided by 6, 5 pi divided by 6, 7 pi divided by 6, or 11 pi divided by 6. Let's look at one more example. We want to find all solutions of the square root of tan theta divided by 2 minus 1 is equal to 0. And first we want to go ahead and isolate our tan theta divided by 2. Doing so gives us that tan theta divided by 2 is equal to 1 divided by the square root of 2. Set our theta divided by 2 equal to alpha. Then we want to solve tan of alpha is equal to 1 divided by the square root of 2. Oops, I made a small mistake. This should be the square root of 3, as should this one. So one thing that we know is that our tan theta or tan alpha, the graph of this has a period of pi, which means we only need to find solutions from 0 to pi here. And since our tan alpha needs to be positive, we're only going to be looking at solutions in the first quadrant. Forming our right triangle, we're going to have a right triangle whose opposite side is 1, whose adjacent side is square roots of 3, and whose hypotenuse is 2. Therefore, this angle alpha is going to be equal to a pi divided by 6. So now that we know that alpha has to be equal to a pi divided by 6, set theta divided by 2 equal to a pi divided by 6. And we're going to add some multiple of pi to the right-hand side to get all solutions. So add plus pi k. And then solving for theta, this gives us that theta is going to be equal to a pi divided by 3 plus 2 pi k. And this is going to be all possible solutions of our given trigonometric equation.